This is ROW number 19. And this just starts out with some information about a deck of cards. Because sometimes we have probability questions that talk about a deck of cards, and some people aren't completely familiar with what's in a deck of cards. So first of all, how many total cards are there in a deck of cards? Yeah. Good. So we got 52 total cards. And then there's something called a suit. And a suit is the hearts or the diamonds. So how many total suits are there? Yes, sir? Four suits. So hearts and diamonds and clubs and spades. Those are called the suits. And then also there are cards that are called face cards. So that means the cards that have people on them. Those are the jacks, the queens, and the kings. And there are jack, queen, and king for diamonds, jack, queen, and king for hearts, jack, queen, and king for spades, and jack, queen, and king for clubs. So that means there's a total of 12 face cards, because 3 in each suit. And then if there are 4 suits, and there are 52 total cards, how many cards in each suit? Yeah, 13. Awesome. So there's 13 diamonds, 13 hearts, 13 spades, and 13 clubs. And then if you add up 13 plus 13 plus 13 plus 13, that adds up to the 52 total cards. Then how many of each color? So some of the cards are red, some of the cards are black. How many of each color are there? Yeah.
26.
Good, 26, because there's 13 hearts and 13 diamonds for a total of 26 red cards. And then there's 13 clubs and 13 spades for a total of 26 black cards. So 26 of each color. And then the 26 plus the 26 also adds up to 52. And then finally, the number of each value. So what I mean by that is how many 2s are there? And also how many 8s are there? 4, good. Because there's a 2 of hearts, a 2 of diamonds, a 2 of spades, and a 2 of clubs. So there's 4 of each value. 4 queens, 4 jacks, 4 aces, etc., etc. All right, so that gets us ready for the first problem. This is number 2, but this doesn't have to do with cards. Macbeth, this must have been written by an English teacher because there's a guy named Macbeth in here. So Macbeth and Sabi are playing a board game, and they're using a die. And the way this board game is set up, if you roll a 2 or an even number, then you get to play another turn. Okay? So we're going to have A be the event that a 2 is rolled. And we're going to have B be the event that an even number is rolled. So in this particular game, I don't know what the game is called, but there's one die that they roll, and you just roll it once. But then if you get either a 2...
Mr. Early,
Yes.
I have Evan Tebow.
Yes.
Pause for a minute, please.
Okay.
Thank you.
Sorry, I couldn't tell the last name. Okay, so in this particular game, if you roll a 2 or an even number, then you get to go again. You get to have another turn. So A is the event that a 2 is rolled, and that's good because then if that happens, you get another turn. And B is the event that an even number is rolled, and that's good because you get another turn if that happens. Okay. All right, so then there's some notation that we haven't, well, we've seen it, but everybody always forgets. So there's this A with the line on top of it, and there's an A with a tick mark. I think most people have forgotten, but does anybody know what these mean? Okay, it stands for the complement of the event. And the complement is everything else. So if A is the event that a 2 is rolled, then A bar is the event that not a 2 is rolled. So a 1 or a 3, 4, or 5, or 6. So A is the event that something besides a 2 is rolled. So the bar stands for the complement, and that means everything else besides the event. There is a slight difference on what the tick mark means. The tick mark means list out what could happen for the complement. So this is 1, 3, 4, 5, or 6. So A is the event that a 2 gets rolled, and then A tick mark or A bar is the complement of that, so it's everything else. Okay, then here's a new symbol that we haven't seen. It's a U, and it stands for union. So we're going to figure out what A union B is. And A union B means, well, the union means put them together. So A is just a 2 gets rolled, and B is an even number gets rolled. So what could happen for an even number? Yeah. That's true. In this game, you get to go again. But if you're, what number would you need to get for it to be even, I guess is what I'm saying. 4 or 6 or 2. So A is rolling a 2, and then B is rolling a 2, a 4, or a 6. So what we have to do is we have to take those two possibilities and put them together. So here, you're fine if you get a 2. Here, you want to get either a 2, 4, or 6. Now, in this case, when you put them together, you just get 2, 4, 6. Because this is getting a 2 combined with getting a 2, 4, or 6. So altogether, that's getting a 2, 4, or 6. Now, in a different problem, you could have a set that was rolling a 1 and then combined with 2, 4, 6. And if you combined a 1 with a union 2, 4, 6, then the answer would be 1, comma, 2, comma, 4, comma, 6. But here it's kind of strange because this is a 2, and if you combine that with 2, 4, 6, you still just get 2, 4, 6. Okay, so that U stands for union, and it means put them together. Okay, so the question says which of the following is accurate, and choice A says that A tick mark equals this, which it does, and choice B says that A union B equals this, which it does. So the answer to number 2, I'm telling you, is A. There's some other choices, but basically we needed to figure out what this was, which we did. We needed to figure out what this was, which we did. And then choice A says that those two things are the same. So anyway, the answer to number 2 is A. So reviewing what bar and tick mark mean, that's complement, and then telling you what union means. Everybody having fun so far? All right, now we're going to move on to number 7. And number 7 is about a survey. and there is a survey of a bunch of families in a neighborhood, and there were 200 families that they asked questions. And they asked questions about what kind of pets they had. So it turned out that 54 families had a cat. And then 80 families had a dog. And then 12 families had both a cat and a dog. Now, my first question would be, are these 12 families counted here? They are. So this doesn't say 54 had a cat only. This says 54 had a cat. So if they have both, then they do have a cat. So they're counted here. So these 12 people, or these 12 families, are counted in the 54, and they're also counted in the 80. So that's the first thing that kind of confuses people about these kinds of surveys. Don't assume that this means only cat. It doesn't. All right, so we're going to have C represent the event that if you talk to a family at random, they do have a cat. So C is the event that a family has a cat. And then D is the event that a family has a dog. So you stop by at a house and you ask a family, do you have a cat or do you have a dog? If they do, then C happened, if they had a cat. And if they had a dog, then D happened. All right, so the question on number 7 is P and then parentheses C/D. So we've seen this slash before, but it's disguised math notation. So does anybody remember what the slash means? Yes. It stands for given. Good. So this is asking for the probability that a family has a cat given that they have a dog. So maybe you stop by at the house and you can hear the dog barking. So you already know they have a dog. And we want to know what is the probability that they have a cat given that you know that they have a dog. Okay, so since you know that they have a dog, how many total families are there that you're considering? Yes. No. 80. Good. Because you know that there's a dog. So the fact that it's given that there's a dog means that there's only 80 families that you're looking at. Is everybody okay with that? All right, so this is going to be a fraction out of 80. Now, Kieran's exactly right. If the question said, what is the probability that somebody has a cat? Then it would be out of 200, right? Because there's 200 total families. But we're talking about what's the chances that they have a cat, given that you know they have a dog. And that's why it's out of 80. Because there's only 80 families that have a dog, and we know they have a dog. So the total we're looking at is out of the dog families. Okay, so then how many families have cats out of the ones that have dogs? Yes. Good. So there's 12 that have both, right? So there are 12 families that have a cat and also have a dog. So the chances of having a cat, given that you know that they have a dog, is 12 out of 80. Is everybody okay with that? All right, then you can reduce that. You can divide 12 by 4 and 80 by 4. So it comes out to 3 out of 20. This question was just a hypothetical question that isn't actually being asked right now. To compare with, if you just wanted the probability of a cat, it would be out of 200. But the probability of a cat, given that you know they have a dog, is out of 80 because there's 80 families that have dogs. All right.